Hi everyone, so in this video we're going to be looking at frequency distributions and their graphs. So a frequency distribution is a table that shows classes of data entries with a count of how many entries are in each class. The frequency, f, of a class is the number of data entries in the class. So essentially, this is just a nice and easy way to group things together. As in, if we have this list of numbers right here, what we could do is say, maybe group together the numbers 1 through 3, the numbers 4 through 6, the numbers 7 through 9. Those would be our classes. 1 through 3, 4 to 6, 7 to 9. The frequency is how many numbers show up in that class. So for 1 through 3, for example, there are 4 of them right there. For 4 through 6, there are 7 numbers in there. And for 7 through 9, there are 5 numbers. That's basically what we're trying to do, is just find classes to be able to group them together and then count how many are in that class. So the class width is going to be essentially how wide those classes are. So like the numbers 1 through 3, that was 3 different numbers, right? So that was a class width of 3 because it was 1 through 3, 4 through 6, 7 through 9. I had 3 numbers in each class. Right? In general, to be able to find the class width, you just take the highest number, the max, subtract the lowest number, so the min, and then divide by however many classes you want. Then you always round up if it's a decimal. And that's going to tell you how many classes, the width of the classes whenever you're making your table. Right? So we'll come back to that and try that in a second. But first, let's talk about the lower limits and upper limits. So the lower limits are literally just the lower end of those classes. So like, remember, in that example we just had, we had 1 to 3, 4 to 6, and 7 to 9, right? The lower limits are the 1, 4, and 7. They say where your class starts. Upper limits are those higher numbers. Tells you where that class ends. So to find the lower limits, what you do is you start at the minimum and you just keep adding the class width to it. So like, in this example that we were just doing, the minimum was 1. Our class width was 3. So if we do 1 plus 3, that gives us 4. If you notice, 1 and 4 were the first 2 lower limits. Then you just do it again. So you can add 3 again. That gets us 7. That was our last lower limit. Now, you'll know when to stop, because if you end up trying to add it again, so if we try to do plus 3 again, that would give us 10. That's actually higher than our max, because in the numbers that we were given, 9 was the max. So why would we need to start a class at 10? That wouldn't make any sense, right? So we're just going to have 1, 4, and 7 as our lower limits. For upper limits, you just take 1 less than the upper limit of the next class. So what I mean by that is for the upper limit of our first class, we would take the second lower limit, subtract 1, and get 3. So 3, which if I put it in yellow, that way we can see that that was our 3 from right there. If we take 1 less than the 7, we get 6. That was our second upper limit. Now, remember that 10? There's a reason I didn't quite erase it yet, because if we take 1 less than that, we get 9, which was our final upper limit. So even though we don't need the 10 to be a lower limit, it does help us find that upper limit. Okay, so let's look at an example. Given that we have data with a min value of 12 and a max value of 77, and given that we want 6 classes, find the class width, the lower class limits, and the upper class limits. Okay, so first off, the width. So remember, the width was max minus the min divided by the number of classes. So in this case, the max was 77. We subtract the min, which was 12, and it says that we want 6 classes. So we're going to divide that by 6. So 77 minus 12 is going to get us 65 divided by 6. And if we actually divide that, we would get about 10.83. Now, we can't have a decimal for our width, so we always just round up. So this is going to be a width of 11. Right? Now keep in mind, I'm not using normal rounding rules here. Even if this was 10.001, we would still round up to 11. Always round up. That ensures that you have enough classes, or rather that your classes go up to your max. Okay, so with that said, let's take a look at the upper limits now. Sorry, that's supposed to say lower limits. By the time it gets to y'all, it'll be fixed, so y'all should say lower limits. So for the lower limits, all we're going to do is take the min, so 12, and then we're going to keep adding that width. So it's going to be 12 plus 11 will give us 33, plus 23, plus 11 will give us 34, plus 11 will give us 45, plus 11 again will give us 56, plus 11 will get us 67, and plus 11 one last time will be 78. All right, now remember, this one, the 78, that's above our max. So we're not going to need a class that goes 78 to something even higher because there's not going to be anything in there. So it's not going to be one of our lower limits, but we're going to keep it in mind for whenever we're doing the upper limits. So these are our lower limits. And if you notice, there's 6 of them, which is good because that's how many classes we wanted. All right, for the upper limits. So remember, for the upper limits, you go to the next one and subtract 1. So we're not going to do the 12, that's the first one, but the upper limit of the class that starts with 12 is going to be 1 less than the next class. So that next lower limit was the 23. 1 less than that would be 22. That's going to be our first upper limit. Then we go 1 less than the 34, will give us 33. 1 less than the 45, give us 44. 1 less than the 56, 55. 1 less than the 67, 66, and then 1 less than the 78. So that's going to give us 77, and that's going to be our last upper limit. Again, there are 6 of them. So essentially what this means is that all of our classes would be 12 to 22, 23 to 33, 34 to 44, 45 to 56, 45 to 55, 56 to 66, and 67 to 77. Those would be our actual classes. Now this question didn't actually ask for that, but that's the idea of where we would go with it. All right, so let's try that one more time. Example 2. Given that we have data with a min value of 12 and a max value of 110, and given that we want 8 classes, find the class width, the lower class limits, and the upper class limits. Once again, that one should have said lower. So first off, width. Remember that's max minus the min over the number of classes. So in our case, it's a max of 110, a min of 12, and we divide that by the number of classes we want, which is 8. So that is 98 over 8, which is 12.25. Again, remember, even though normal rounding rules say we should round that down, we're just always rounding up for this class width. So we are going to have a class width of 13. All right, next up, the lower limits. We start with our min, so 12, and then we're just going to keep adding 13 to it. So 12 plus 13 would be 25. 25 plus 13 would be 38. 38 plus 13 would be 51. 51 plus 13 would be 64. 64 plus 13 would be 77. 77 plus 13 would be 90. 90 plus 13 would be 103. Now for the record, we already have our 8. So again, these are all of the lower limits, but just so we have it for easily doing the upper limit, if we did add 13 one last time, we would get 116. Just remember, this one right here is not a lower limit. We're not going to put that in our answer for a lower limit. We're just going to use it to get that last upper limit. That's it. All right, so for those upper limits, we're going to start with the 25 and subtract 1 from it. That'll get us to 24. Then subtract 1 from the 38, get 37. From the 51, get 50. From the 64, get 63. From the 77, get 76. From the 90, get 89. From the 103, get 102. And lastly, from that 116, we would get 115 as our upper limit. And that is all 8 of our upper limits. Now, for the record, if you notice, that upper limit actually goes above our max, but that's perfectly fine. So our last class would be 103 to 115. But that's perfectly fine because our max of 110 can go in there at least. That's what we're primarily concerned about, is getting classes that are big enough to make sure that all of them fit, and that we don't have just any extra classes left over at the end that nothing would actually go into. So since our 110 does go into that last class, that is perfectly fine. All right, couple more things to talk about these frequency distributions before we kind of start to make a little bit bigger of one. So the next one is going to be midpoints. So the midpoint of a class can be found by adding the lower and upper class limits and dividing by 2. So you just take the lower part of that class plus the upper part of that class divided by 2. That's the midpoint. The relative frequency is the percentage of the data that falls into that class, found by dividing the frequency of the class by the sample size. So it's just frequency divided by sample size, right? Or F over N. Okay. Lastly, the cumulative frequency. That's going to be the sum of all the frequencies in that class and all previous classes that came before it. The cumulative frequency of the final class should be 100% or 1. So that cumulative frequency, think of it kind of like a running total. You're just going to keep a running total as you go, and if you do everything right, it should end up being 100% or 1. Now, with that said, for our examples, every once in a while, because we are going to be rounding some of this stuff, you might end up with 99.9%. Or instead of 1, you might get 1.001. That's just a little bit of a rounding error. That's perfectly fine if that happens. But if you get something like 150%, or if you get like 1.5 instead of 1, that's when something probably went wrong. Right? Now, for this class, we're usually going to be talking about decimals, so the 1 is the one that we're going to be shooting for, not the 100%. Okay. So let's go ahead and look at an example that kind of takes all of those things into account, and we can start going through how to do them. Given the following frequency distribution of the grades of 100 students on an exam, find the midpoint, relative frequency, and cumulative frequency for each class. So if we start with the class that's going to be 60 to 69, has a frequency of 12. So for midpoint, we do lower plus upper divided by 2. So that would be 60 plus 69 divided by 2, which is going to be 64.5. For the relative frequency, we take the frequency, which in this case is 12, and divide by the total sample size, which we know was 100 students. So we can just divide it by 100. Now, for the record, if the problem doesn't give you the fact that it was 100 students to begin with, or how many students it was, then you can also just add up all of the frequencies, and that would get you the sample size, because these classes have all of the information in them. So if you add up those frequencies, that would be the total that you would divide by. But in this case, it already gave us that it's 100, so we don't have to worry about that. All right, so 12 out of 100 would be 0.12. And for cumulative frequency, since right now we only have 1, it is also just 0.12. All right, so for the next class, again, midpoint, we take the lower limit, 70, add that upper limit, 79, divide by 2, so we're going to get 74.5. For the relative frequency, we're going to take 18 and divide it by 100, so 0.18. And this time for the cumulative frequency, all we actually need to do is take that frequency that we had under the cumulative before, add on the 0.18 that we just got, and that would give us our new cumulative frequency of 0.30. Then we're just going to do it again. So for 80 to 89, we have 80 plus 89 divided by 2, which is going to be 84.5. Relative frequency would be 43 over 100, so 0.43. And then to find that cumulative frequency, we take the previous cumulative frequency, so 0.3, add on our relative frequency that we just got, so 0.43, and that gives us a new cumulative frequency of 0.73. All right, last time. This is going to be 90 plus 99 over 2, so 94.5. The relative frequency is going to be 27 over 100, so 0.27. And lastly, we are going to do the previous cumulative frequencies, 0.73, add our 0.27, and in this case, we get exactly 1, which is kind of like a check for us that we know we probably did that part right. All right, last part of these notes. A frequency histogram is a graph that uses bars to show the frequency distribution of a set. So given the following frequency histogram, find the number of classes, class width, the highest frequency, and the lowest frequency. Okay, so this graph just shows us in a bit more visual way what we were putting in a table before, right? All of these numbers at the bottom, all of those are midpoints of the classes. All right, so those are the midpoints. It doesn't actually give us the entire class. But that's okay, because we can figure out all of this stuff anyway. So first off, number of classes, that one's really easy. You just count up the number of midpoints or the number of bars that you see. In this case, there's 5. So there are 5 classes. For the class width, you can actually just use the midpoints. So if you look, to get from one midpoint to the next, you'd have to add 11 to that 5. Same thing for the next one, and the next one, and the next one. If you add 11 to any of those, you get to the next one, right? So the class width is actually that 11. So you can just take 2 of the midpoints, find the difference between them. All right, the highest frequency. For the highest frequency, we just have to look up and see the tallest graph, which is going to be this one. We follow it over to the side, and we see that the highest frequency is 25. And then lastly, for the lowest frequency, here's our lowest graph down here. It happens to be on the left, so we don't even have to follow it over. We can see it's exactly at 5. And that's everything about frequency distributions and histograms. So this should be enough to be able to go start on your homework. Let me know if you have any questions. Thanks for watching.